You are holding your smartphone, and the battery is completely dead. You press the power button, and you get nothing but a black screen. It feels like the device is entirely empty. Your dead phone is actually packed to the brim with electricity. Inside the copper wires, millions of tiny particles are vibrating, colliding, and moving randomly. That chaos is exactly why your screen is black. The energy is sitting right there, but because the particles are bouncing aimlessly, no work gets done. Think of a garden hose lying perfectly flat on your lawn. The hose is full of water from end to end, but nothing is coming out of the nozzle. To spray that water, you need a hard push from behind to get the water moving, and you need a steady flow. Electricity is the organized, single-direction movement of the particles that are already sitting inside your device. Let's look at how we create that movement. In our plumbing setup, a single drop of water is what we call an electrical charge.
Imagine walking into a candy shop and asking to buy 22.3 grams of a wrapped piece of candy. The shopkeeper would tell you it's impossible. Buy one whole piece, or 2 pieces, or even 3. Electrical charge works the exact same way. It is an unbreakable unit. So how do we get all of these individual, stubborn charges to stop bouncing randomly and march in the same direction? Look at this water tower. Pressure builds at the bottom, forcing water out aggressively. This pressure is voltage. Batteries have a high pressure and low pressure end, creating an invisible shove. That push makes lazy, bouncing charges instantly line up and sprint together. Voltage is the pressure that forces random particles into an organized line. We have the pressure, and the charges are finally moving. Now, we need a way to measure the strength of that flow. A plumber measuring a hose doesn't count the total water sitting inside it. They measure the rate of flow, how many gallons pour out in 1 minute. Electric current is the exact equivalent. It measures how many charges pass a specific point against a ticking clock. To find the current, we divide the total charge crossing a gate by the time it took. Watch the gate. A standard charge bundle is a coulomb. 1 bundle passing the gate in 1 second equals 1 ampere of flow. Current tells us how thick the stream is. It is the measurement of how many charges pass the gate in a given window of time. Let's go back to that dead smartphone. You grab a charging cable and plug it into the wall. The wall outlet connects those dormant particles in your phone to a massive, city-sized water tower. The grid supplies the extreme voltage, the pressure, needed to shove those particles into a neat line. As they rush forward, that steady rate of charges ticking by every second, the current, powers your screen and fills your battery. Electricity is easy to understand once you remember the simple mechanics of water pressure, droplets, and a ticking stopwatch.